Well, welcome back. Hope everybody had a good Thanksgiving. Some of you may still be traveling. I don't know. If you are, hopefully traveling safe. If you get the opportunity to do this weekend, go ahead and I hope you do this lesson. If not, I'll give you the opportunity on Monday. Okay? All right. I'll see you on Monday. Now let's get started. All right. Hudson is choosing a seat in art class. He scans the room and sees a four-person table, one bucket of art supplies, a six-person table with two buckets of supplies, and a five-person table with two buckets of supplies. Which table should Hudson choose if he wants the largest share of art supplies? Support your answer with pictures. All right, if you want to try this on your own, go ahead and pause the video. If not, and then you can start again, you'll see how I solved it. Okay, all right, so this is a picture is worth 1,000 words. So I'm going to start by just drawing a representation of the problem. The first one said there was a four-person table, and here's 1, 2, 3, 4, and it says it has one bucket. I'll put an X for the bucket. Okay. The next one says it was a six-person table. Okay. So I'm going to go with 1, 2, 3, 4, 5, and 6, and we can see there are 6 people around it, and it says they have 2 buckets of supplies. And the last one says it's a 5-person table, so 1, 2, 3, 4, and 5, and there's 5 people around it, and there are 2 buckets of supplies there also. Now, he wants to choose a seat where it has the most supplies. So here we can see we have one bucket divided by 4 people. So that's so he would get 1/4 of a bucket. Here I can see I would have 6 people, 2 buckets, and I'm dividing that by 6 people. And the last one would be you have 2 buckets and you're dividing it by 5 people. Now, right off the bat, I can see that that I've got to compare these fractions. Okay. Well, right off the bat, looking at this, that both numerators here are the same. Since both numerators are the same, I know that if I cut up the pie into more pieces, my pieces are going to get smaller. So 2/5 is definitely going to be larger than 2/6. So now I want to compare 2/5 and 1/4. Well, I can see both of them would have common denominators of 20. So I'm going to do that. I like comparing my fractions by creating equivalent fractions. In order to get 5 to 20, I have to multiply 5 times 4 here. So I'm going to go 2 times 4. And that gives me 8/20. And over here, I've got to go 4 times 5. So I'd have to do 1 times 5. So I can see that 2/5 would be the larger portion. So obviously, he would want to sit in the 5-person group. Okay, we're still working on the standard, which is interpret a fraction as division of a numerator by the denominator. Solve word problems involving division of whole numbers leading to answers in the form of fractions or mixed numbers by using the visual fraction models or equations to represent the problem. Now, that's you notice it's in red is interpret a fraction as division, and we're also going to be using it to solve word problems, kind of like what we just did with the application problem. Okay, all right. Okay, our lesson objective. I will be able to solve word problems by interpreting a fraction as division problem using visual models. Such a question, how can visual models help me solve word problems by interpreting a fraction as division? All right, let's take this first problem. It says a baker poured 4 kilograms of oats equally into 3 bags. What is the weight of each of the bag of oats? Well, you can see the 4 squares here are representing our 4 kilograms of oats. And it says it wants to split into 3 bags. So I'm going to take each one of these kilos and I'm going to split it into thirds. Now you can see that here I have 3/3. Here I have 3/3. Here I have 3/3. And here I have 3/3. So if I wanted to split these up equally to 3 bags, I can see I would take this 3/3 to here, this 3/3 to here, and this 3/3 to here. Now this 3/3, I would have to split up the individual thirds. I'll put 1/3 here, that'd be 1/3, and our 3/3. And I'm going to take this 1/3 over here, because we had 3/3 and our 1/3. And I'm going to take this last third all the way over here, and we're going to have our 3/3 and our 1/3, which now gives me 4/3 in each bag. So we know 4/3 is actually equal to 3/3 plus 1/3, so we know that's 1 and 1/3. Now that's by taking up the whole and splitting them up into 3 equal parts. Now there's a simpler way, but I want you to be able to see that the division problem here was 4 divided by 3 equaled 4/3. Okay, that's what I really want you to see with this model. Now the tape diagram shows a little simpler, but you're going to come up with a different answer or equivalent answer of 1 1/3. But I really want you to see that 4 divided by 3 equals 4/3. Now let's take a look at the tape diagram. Now in the tape diagram here, first off, we know that the top would have been equal to 4 kilograms. And we split it into 3 equal parts. And we know that each part, since there's 4 divided by 3 parts, would be 4/3. So there's 4/3 there, 4/3 here, and 4/3 here. So now we can see that we would have same answer, 3/3 plus 1/3, which gives us 1 and 1/3. See, tape diagram's easier, it's more efficient, and you still get the same answer. Let's take a look at the next problem. In this next problem, it says if the baker doubles the number of kilograms of oats to be poured equally in 3 bags, what is the weight of each bag of oats? Well, once again, let's start with our total. And we know that from the previous problem, it was 4 kilograms right here. So now it's 8 kilograms. Now we're still just dividing it into 3 different bags. So each one is 8 divided by 3. So 8 divided by 3 gives us 8/3 in each bag. So 8/3, which would equal to 3/3 plus 3/3, which would be 6/3 plus 2 more thirds. So that would equal 2 and 2/3 kilograms in each bag. Okay. This time it says if the baker doubles the number of kilograms of oats to be poured equal into 3 bags again, what is the weight of each of the 3 bags? Okay, so the only thing we're changing our problem here is instead, now this is, since it was 8 kilograms last time, now it's going to be 16 kilograms. And we're still going to be splitting it up into 3 equal bags. And we know that means it's going to equal 16/3 in each bag. Now, let's come down below here because this is what you're going to have to do in your problem set. And the division expression. This is 16 divided by 3. Okay, we'll go back to unit form in a minute. Improper fraction, which I don't like the word improper. That's just a fraction that is going to be greater than 1. Okay, and we know by the answer we have that's 16/3. And 16/3, if I were to split this up into thirds, I would have 3/3 plus 3/3 plus 3/3 plus 3/3 plus 3/3, which would equal 15/3. And so I can see that'd be 1, 2, 3, 4, 5. And the other way to do it would be 3 equals 16 5 times, because it'd be 15 and 1/3 left over. Now, let's talk about unit form. Here we've got 16 ones divided by 3 ones. Okay, in some cases that would help a lot, but we're using the same thing here. We're talking about tens, so 16 ones divided by 3 ones. Now the standard algorithm. If we were going to do this division in standard algorithm, we'd take 16, we're dividing that into 3 bags. And we know 3 would go in 16 5 times. 5 times 3 is 16. When I subtract, 15. When I subtract it, I get 1 left over. And our remainder we write as a fraction being 1 slash, and our divisor was 3. So it's 5 1/3. And that's what you're going to be doing when you do your problem set. I'm not so worried about the unit form section of it over here. So you can actually just scratch the unit form. For this problem set, I'm really worried about the division to a fraction greater than 1, to mixed numbers, and standard algorithm. Okay? All right, go ahead and start your problem set if you're doing this in class. All right?